One important topic before we start, I would like you to first read the report or try to do it vulnerability after vulnerability. So for example, if I try to talk about first high issue, first read it yourself, try to understand it, and only then hit play and listen to what I'm saying, then you will get way better results compared to you just mindlessly watching this video. Do you want to know how to win $15,000 for a single finding in Code4rena? Well, I have something for you. In recent Wiselending content, we did just that. We had a solo finding that gave us 15 grand and allowed us to have third place in the whole contest. But before diving into report, I'm Delirious, I'm independent security researcher, and together with my friend Sorry Not Sorry, we found that Duplicate team, and now we are doing competitive audits and private audits. So if you want to see how we found this unique high finding and you want to learn something from it, please stay with me. So I can tell about Wiselending because the report is out. Unfortunately, we participated in one of the invitational audits, which was private audit in Code4rena, and we cannot share findings that we found. This is very unfortunate because we won this contest. We also received the hunter and gatherer bonuses. If you don't know what it is, those are bonuses for the biggest amount of issues found and for the most unique amount of issues found. So we managed to do that, but unfortunately the report won't be public, so we won't be able to share it. However, without any further ado, let's continue with Wiselending. So this is the report. You can see there was like 5 high severity findings and 17 medium severity findings, and something that is not really found too often is that there was a lot of unique findings and not a lot of duplicates. This was due to the fact that the code was, first of all, complex, and second of all, there was so much code abstractions that it was really hard to get a grasp on what is calling what other function. And I had some of my friends that I contacted, and they said that they tried to do Wiselending, but they failed. And they didn't fail because like they tried and then they failed, but they looked at the code and the code was really hard to understand for them. And they say, okay, I'm gonna try my best at some other content. So this might be a first tip for you. If the code is hard for you, it is also probably hard for the other people. So don't get discouraged by just the fact that the code is hard, because we are all humans, like people that have more experience, maybe, understand the code like 2 times quicker or something, but it doesn't mean that, there is so much of a distance between you and them, and just showing up and trying your best and then, learning your lessons from it is very valuable lesson. But before jumping into the report, a few words on what Wiselending is. So this is just a borrowing and lending protocol, collateralized debt position, in other words. And what's new about Wiselending is their LASA, which is their AI-driven calculator, which just calculates how much you have to pay for the borrowing and for lending. So there is no some constant formula, for example, as in Aave or Compound. But here we have some AI that calculates how much should people really borrow to have the best rates for both borrowers and lenders. And this is the new approach. And having said that, this is our team. We placed third. So we had one high, which was solo, and one med, which was not solo, but only one other but only one other person found it. So yeah, just with those two out of, like 5 highs and over 10 mediums, we placed third. So this is what really means to have unique finding on Code4rena. Because if you found something that, let's say, 10 other people found, you will probably get pennies from it. Okay, and let's dive in. So first finding is exploitation of receive function to steal funds. So Wiselending has similar concept to Compound, that it has the central contract that is a keeper. So it holds the most important infos about the project. It also verifies if some actions are possible or not, just as comptroller in Compound. And in case of this protocol, it also locks the protocol with reentrancy flags. So you may have a reentrancy lock, not for the single contract, but you may have it for the whole protocol. However, what people found is that you may actually reset that. So you can see here that we have this function send value, and first of all we are putting send progress to true, then we are executing the call, and finally we are setting it to false. So what does that mean? So you can, in this particular case, just create some other function which inside calls a function that uses this send value, and because it does not check if sending progress was true before, it is being reset to true again. Then you can call recipient and the flag will be reset. So you are effectively breaking out of this reentrancy flag. And next up, what people found was this particular case. If user deposits 1 ether and borrows half of ETH, and then calls withdraw exact amount of ETH to withdraw 1 ether, at the end, of course, it should not be possible, and the contract would revert because, first of all, you deposited something, you borrowed for the half of the amount of money that you put in, but then you withdraw everything. So you have no collateral at this moment, and you have half of ETH of debt. So normally you could not re-enter into the contract and, for example, liquidate yourself. But here, because you can reset this flag, you can actually go ahead and liquidate yourself. And additionally, not only that, you can pay back your bad debt. So you can, from a single ETH, you take home 1 ETH and another half of the ETH. So what could allow you, for example, to find this particular issue? If we think about it in a broader sense, it is, if you have some very critical variables, you should probably check all of their usages and have in the back of your head what this particular variable is meant to be doing. So in this case, if the variable is meant to be a reentrancy lock, and you just see all these different changes, then you can ask questions. Okay, so if this is set here or read here, how can I go ahead and do something that the developer didn't think about? In this case, what they didn't think about is to protect themselves against leveraging the lack of check if this is already true to reset the reentrancy flag. Next up, second high. This is the high that we found. User can erase their position debt for free. Actually, this title is a bit misleading, because what really happens here is that you can erase your collateral token, and because of that, you can borrow as much as you wish, which means that you can actually take all of the money from contract. So because we found it, I can share with you how we found it. It was like complete protocol drainer. If we haven't found it and some hacker did, he would definitely take home everything that Wiselending had. So when we looked through the code, we found this function called remove position data. So what this function does is it just goes through the user tokens and deletes it. So the thing is that Wiselending holds all the collateral tokens that you have in an array. So if you are, for example, borrowing USDC or borrowing DAI or borrowing some comp tokens or any other tokens, they all are added into the array. And then, for example, if you repay your whole debt, there is like no really reason to hold your token which has no balance. So this function is used to actually go ahead and remove this token from the array. But there's like, when we first saw it, there was something strange about this function. This was very suspicious. If length is 1, just delete last position data. And you know, this immediately, the alarms went off in my head here. Like, why are you not verifying, even if there is only one token, that the token is actual pool token? And the second alarm rang for me in this while loop. So what we do here, if our I is end position, no matter if we found the token or not, we are deleting the last position. And if not, we are just going ahead and like continuing. And if it's somewhere in the middle, we are removing the token from the middle. But those two cases were really, really very suspicious to me. And at first, because I didn't find any immediate path to this, I just, marked it to check later. One more thing I want to add here, you can see that they're passing around functions, and they are using functions as parameters to other functions. That's why it was so hard to find it, because they use this pattern constantly in their code, and you never know what really function they will be using. That's why all the help that you have from your LSP, from IntelliSense, from any engine that helps you, to move around the code doesn't work. In this case, this is like one of the things why it was so hard to navigate through this code. But then finally, I found out, like, first of all, I found the possibility to really remove, to execute, to reach this path through the admin function. This was not ideal, but still, I thought that it might be possible. And this is when I started, when I, have the initial goal, I started to think, okay, I know what is the end goal. If I am able to pass any token that is not in the user array, then I will just remove the last token. So this is cool. If I'm able to remove some token that I have debt in, that means that maybe I can clear my debt. That was my thinking. So I went through this admin function, and I think I then found that yes, there is no protection, but still this is admin function. So this is not good for me personally, because like if this is clear admin stuff, like probably low, maybe with really good reasoning, it could be a medium severity. But at that moment, first of all, I didn't know if there is another path, and I also didn't know what are the real consequences of that. I really thought that what will be done here is that you can erase your debt, and that's cool. Like, for example, you take all the debt that protocol has and you don't have to repay it. And then I searched more, and it took way longer than I expected because of all these issues that I told you. Yeah, I had literally to grab by the function names everywhere and look through the connections, write down, what functions really are used inside. As I said here, for example, this is just passed as a parameter, but outside this function is called differently. So I had to write it down on a sheet of paper, and finally I was able to find it, just because I thought that if I am able to remove this token, then I will, like, really something bad will happen. And yes, I finally found payback bad debt, no reward. So this is function, what it does, if some position has bad debt, so the collateral that they have is not enough to pay for their debt, the protocol accrues bad debt. You are passing nftID, which is the position ID. You are using payback token, and you are using shares here. So if the total deposit shares is 0, then just revert, because the pool is not active for the user. But actually, fortunately for us, this is not the user total deposit shares, but general deposit shares. So if any other person has deposit shares in this token, we are okay. And I guess that, also that when developers wrote all those checks, maybe something slipped through their head, and like, how it is. Sometimes you're writing code, you're thinking about something else, you are doing some protections, and then you think, oh yeah, I already take care of that, but you didn't. But this just happens because we are just humans. So the thing is that nowhere here actually anyone checks if user has this pool token. But the problem was to have a payback amount, because another problem was that if you pass some amount, it will be trying to be matched against user debt, this payback amount. And of course we want to pass some token that user doesn't have. So at first moment I thought that this will be hard, maybe impossible, because we can remove the token only if afterwards it has 0 shares, and here we should have non-zero payback amount. because it's used later. But then I thought, what if I pass that I want to pay back 0 shares? Of course it worked. There is no check for that. Unfortunately for me, I went through the path in my head and I said, oh my God, this will work. If the precondition for that is that the user needs to have the bad debt. And concerning this bad debt, there's additional thing that was a bit funny later when we found it out. Actually, when we were writing report for this finding, we found also that there is no check of how big the position is. So you could really create a dust position, for example, for 1 way, for 2 way, for 3 way, like any position that will not be really economical for the liquidator to liquidate you. And we also wrote about it, but actually this is another issue, and some other people they wrote report for this issue that we also described here, like partially, and then when I saw the report for that vulnerability, I was like, oh my God, like we didn't report it. I was convinced that we reported this finding, but we didn't. Like, things happen. Like, so another tip for you, if something is suspicious, just write it down for later, for checking out, because we did not write this down, so like we missed this vulnerability. Like at least we were not granted anything for it. So in my initial thinking, it was like, still you need to have some big position that will accrue bad debt, and then that you have second very small position that will accrue bad debt, and then when the bad debt happen, you may pass like 0 shares. Like I thought that you need 2 positions initially, just because if you have 2 positions and then you are updating them when you are performing operation, that really accrue this bad debt for you. But this was like wrong, and I only learned that later when I was preparing proof of concept. And actually, initially, this issue was rejected because neither the scout nor the judge thought that this is valid. And actually, also sponsor said that this is invalid finding, and he has his justification for why this is not valid. And then post-judging QA came, I wrote the POC, and then I found out that you don't really need this big position. Like any position that will accrue bad debt will suffice. And then you are removing the token. And then when the token is not there, when you are taking that, there was like, if I remember correctly, the situation was that the debt was still there, but the amount of tokens you had was 0. So then when you took any debt, it first read how much collateral tokens do you had, and it returned 0 because you just removed the token that you didn't use. So your health check was always bigger than 1. It was always bigger than 1 because you didn't have this token, and the number of tokens that you had was 0. The for loop that iterated through all of your debt didn't run even once. So no matter how much debt you took, you were always healthy. So you can go ahead, go to the bank. Imagine this situation. You have bank, you are going to the bank. You said, okay, I have bad debt. So I have bad debt in Canadian dollars. So I'm gonna repay 0 of my bad debt in American US dollars. And they go ahead and say, okay, we see that you have 0 debt. You want to repay 0 shares. Okay, so let's remove the last token that you have. And then I go ahead and I say, you know what? Out of all my accounts that I have, please, give me all you have. Okay, and they said, we'll see, if your collateral is okay. And they go ahead and see, okay, you have 0 debt tokens, 0 debt after this operation. This is cool. Go ahead, take all of our money. So this is this particular case. And there's a bit of drama about this finding. Actually, sponsor appealed this finding, that he found that our POC was not about the real issue. And yeah, I admit, the proof of concept, like my initial thinking that you need those 2 big positions, like 1 big position and 1 small position, it didn't have to be like that, because when writing POC in post-judging QA, I found out that it's really way simpler than that. But the question is now why I haven't written the POC in the first place. We didn't do that because we were participating in some other contest, and we jumped in the middle of Wiselending contest. And here I don't want you to think that this is something that you should do. If you have some feeling, don't verify it and just go ahead and without any POC report it, and maybe it will be good. Probably it won't. In this particular case, I was 99% sure that it will work. Actually, I was convinced that it will work. I just made one wrong assumption about the code, but still the root cause, the path leading to this issue was correct. What was incorrect was that the requirements for this issue to happen, which were just way simpler than I thought initially. But please, if you are not sure if something is real issue, don't report it. If you just have a feeling, it's better to verify it, write some POC, because sometimes it's really hard to write a POC for a specific case, because it may be really big and really hard, but still you can just extract the root cause, just few lines of the code. Usually it's few lines of the code than if you even hard code some values and then you write a test and you see that it really behaves the way that you think it will, then probably it might be really working. But if you just saw something and you thought to yourself, this might actually be an issue, it might not be an issue. And actually, there were people that were not awarded anything just because they reported a bunch of low quality reports, or the reports that were really rubbish. Let's just say they were rubbish. They were just trying to get some money, just pressing the judge, or for example, finding a bunch of invalid issues and not verifying them really well. And in these cases, those people, even though they had some issues that were valid, they didn't receive any reward for that. Don't do that. Please do verify your issues. I verified this particular path because before post-judging QA, that this particular part will really remove the token, that it shouldn't. I knew the path. I just was not sure of the initial requirements that should be there. Okay, explanation of it took a while, but I hope that you learned something new from it, and maybe you will have now some different perspective on how to look for bugs and how to look at the code to find the most of the code. And yeah, let's go ahead. Next we have incorrect bad debt accounting can lead to state where claimFeesBeneficial function is permanently bricked and no new incentives can be distributed, potentially locking pending and future protocol fees in the FeeManager contract. So there was FeeManager contract which received all the fees. So for example, you do any action in the protocol and the protocol takes some fees. In case of Wiselending, there was specific FeeManager contract that received those fees, and then you could claim them. But you can claim the fees only if the total bad debt is 0. If there is bad debt in the protocol, you cannot claim anything. And here you can see that in set bad debt position, you are setting bad debt to the amount and you are setting it, while here in increased total bad debt, you are not setting it to amount, you are increasing it by the amount. So let's imagine a situation. You have bad debt and you have like 1 Ether of bad debt. Someone comes and liquidates 1/3 of your position. So then your new bad debt position is 0.7 ETH, around ballpark of that. And you are setting it to 0.7. But here you are increasing it by 0.7. And then someone comes along and liquidates like just 10%. So now you have 0.6 of Ether of bad debt, but it increases by 0.6. And if you do partial liquidations, you can inflate this total debt so that even if it's completely repaid by everyone in the protocol, the total bad debt in ETH will count it as if there was bad debt. So now no one is able to get any fees from the protocol. So what can you do here to find such issues in the future? Very important lesson to learn here is sometimes the protocols devs use the global counter and local counter per user counter, and you should look very carefully for that places when and how they change, and if they always change in the same way. In this case, the problem was that you can actually set one of them and increase second of them, but it can be generalized to just the case that if you have global and local counter, always verify that they work the same way. Next one, liquidators can pay less than required to completely liquidate the private collateral balance of uncollateralized position. First, a bit of knowledge. In Wiselending, you can either deposit something in order to borrow, and you may have also the private deposit, that the one that cannot be used for borrowing, and it does not really count from the perspective of borrowing collateral. So next up is liquidators can pay less than required to completely liquidate the private collateral balance of an uncollateralized position. So the case here is in Wiselending, you may have your private balance that cannot be used for borrowing, add your borrowing balance that you can take the loans with it. So let's say that we may have a situation that you have like $1,000 of your private deposit and $1,000 of the normal deposit. So let's say that you, out of this, all the monies you have, your collateral is treated only as $1,000. And the problem here is the check if you are under collateralized or not is checking your normal balance. However, when calculating how much to take, how much liquidator can take from you during liquidation, they are getting your full collateral in Aave. So as the warden explained here, user deposits $100 worth of Aave in his private balance and the same amount in normal balance. And let's say that, you know, he's then liquidable. The liquidator pays $50 of raw Bitcoin to liquidate the 50% of WEF, but also it's taken from his it's taken from both of his private and public balance. So that means that the user not only has slashed what the liquidator should slash from him, but he also has the same amount from his private balance. So they actually lose twice, and liquidator actually gets this money. What can you do to find issues like that in the future? I do think that the good heuristic for that is always ask yourself if there is some common pattern, like in this case, you have your collateral, what is different than the common pattern? So in this case, you may have both your private collateral that cannot be used for borrowing and public collateral that can be used for borrowing. So if you identify the places when the current contract is different from how other people are doing it, then dig deep inside of this particular niche, because probably if it's unique in some way, there probably is some unique error inside as well. And the last high I have is wrong use of nftID to check if PowerFarm position is Aave position. A bit of context here. All the positions have NFTs assigned to them. And actually, if this is a position that is Aave position, so for example, the Wiselending takes your money and then puts it inside Aave, you have another NFT. And they are actually checking this by assigning the NFT ID as Aave ID. But the problem is that they actually have two NFTs, two separate NFTs for that. So you can actually have two NFTs with the same ID, and one is from Aave and the other one is not. And the issue is there is a check. If checks if this is Aave position, and it's done against Wiselending NFT ID instead of PowerFarm key ID. What does that mean? That you can actually check for non-Aave position in Aave, and of course, if this is not Aave position, it will return you 0. That means that some positions could not be liquidated. So what lesson stems from this issue? And of course, how can you find such issues? I do believe that, again, this is similar. We have some duplicated state. We have state of positions in Aave and not in Aave. And then this is very hard to really make sure that the similar state is kept separate and does not interfere with each other. And those are definitely places that you want to really, really dig down into if you are searching for bugs. And now those are all the high issues that are there. There are 17 medium issues, and I will definitely cover them. but I will cover them in the next videos. So I hope you learned something from I hope you gained some new perspective on security research, on finding bugs, on some ideas how to find bugs. And with this knowledge, you will be better security researcher than you are today. And see you in the next one.